Okay, so this is the burning sticks example. It is a Math 3051 task question that asks you to do quite a few things. So I'll put the question up here so that everyone can see it, but it'll be pretty small. A is burning sticks in a fire. A starts with 90 sticks and is burning 5 sticks per minute. So let's start with the graphing. I'm going to draw a graph. I'm showing where my y and x axes are, and A burns 90 sticks. So I want to make sure 90 will fit. I'm going to make sticks my y, so x equals y equals. X is going to be the number of minutes. Y is equal to the number of sticks remaining. Now, how do I know that? Because I see in the question 5 sticks per minute for A. Sticks per minute is a dead giveaway that that is a slope, that 5 is the slope in a linear equation, and therefore the 90 sticks is the y-intercept. I'm looking at the unit. Sticks per minute is y unit slash x unit. This happens so often, especially with linear functions, that it's a clue. So that's how I'm doing this. So y is the number of sticks, x is the number of minutes, and I said I have 90 sticks for A, so I want to make sure 90 will fit on here. So I'm at the point of scaling my y-axis. B also has 90 sticks, so that's going to fit. C has 1/3 as many sticks as A, so there's an extra little step, an extra little hoop for you to jump through if you want to answer this question. They didn't just say how many sticks C has, you have to figure it out. Well, 1/3 of 90 is 1/3 times 90, which is 30. So 30 has to fit. Okay, so if I go up to 100 on this axis, 30 and 90 will fit. So I'll put 50 here, I'll put 25 here, and I'll put 75 there. I'm not writing the 50 because my label's in the way. Now, why am I not worried about the number getting higher? Because they're burning the sticks. So I can see by the situation that the number of sticks is going to get lower, not higher. They're not collecting sticks. So therefore, I'm expecting a negative slope for these straight lines. 90 is going to be about here. And A is burning 5 sticks per minute. Where do I put the line? I know it's tilting down, but where do I put it? I want this to be good. I don't want to mess up my drawing. So wait, if they have 90 sticks and they're burning 5 per minute, why don't we divide 90 divided by 5? And the answer is 18. It means it's going to take 18 minutes for A to finish their sticks. So we want 18 to fit here. B is burning the sticks twice as fast as A. B's 90 sticks will be burned after 9 minutes because B is burning 10 sticks per minute, twice as many sticks as A. So therefore, 9 minutes has to fit. That's easy. 9 and 18 need to fit. C has 1/3 as many sticks as A, which we've already figured out is 30. I'll put a dot on 30 for C. And is burning them 1/5 as fast as A. Well, 1/5 of 5 is 1. C is burning 1 stick per minute. It's going to take 30 minutes for C to burn all 30 of C's sticks. So therefore 30 has to fit. So 9, 18, and 30. I'll put 30 here. So this will be 15, but I'm not going to write it. And let's say 20, 25, 10, 5. Well, it's a little bit crooked, but I'm not using a ruler. If this is on an exam, I'm using a ruler and graph paper, of course. Okay, so we could fit our numbers here. So it takes 18 minutes, which is going to be right about here, for A to finish all of A's sticks. Where's my ruler? Here's my ruler. Okay, so let's start at the point 090 and finish at the point 18,0, and we have graphed A. I'm going to put an A here to label it. Now B started at 90 also, but burnt their sticks in 9 minutes. So I'm putting a dot at 9 on the x-axis, and I'm connecting it to that same y-intercept. and this is going to be B. I'll put B's label out there. Now C is taking 30 minutes to burn all the sticks, and started with 30 sticks, so I'm connecting these two dots. And there's C. I've done it. I've graphed all three of them on the same coordinate plane. What else were we asked to do? We were asked to find their equations. So to find the equations, well, we already have figured out a lot of the information we need. We have straight lines in the form y equals ax plus b. B is the y-intercept. We already know the y-intercepts for A and B are both 90. So for A, y equals, I need a plus 90. A burns 5 sticks per minute, so should I write 5x? No, they're burning them. They're less sticks over time. It's a negative slope. It's negative 5x. So interesting how this question never really said anything telling you there's a negative sign there, but the information is still there for you to figure out that it has to be a negative slope. For B, B was burning the sticks at 10 sticks per minute, so it's negative 10x plus 90. And for C, burning the sticks at 1 stick per minute, that's y equals negative 1x, or if I want just negative x, plus 30. There's the equations. Okay, we're back in our burning of sticks example, which is up here, and this time we're answering the questions about the transformations. It asked, what transformation will turn A's line into B's line? And, separate question, what transformation would turn A's line into C's line? Well, now that the lines are on the graph, it's much easier to see this. And the warning is you have to answer this using transformation math language. So there's a lot of ways of saying, for instance, A is higher than B or something. You're not getting the marks for that. What we're looking for in this case, in both of these cases, is a rotation. A will turn into B if you rotate A clockwise around the point 0, 90. So I'll use shorthand to say A turns into B if you, I'll say, with a clockwise rotation around the point 0, 90. This is a math language way of answering. It's funny because students really don't want to have to answer questions like this. They really draw a blank when they're asked, transformation, what do you mean? But the students are able to learn about the rotation. And it's not really that hard to draw a rotation. If the student just knows the language that goes with the rotation, then it becomes very easy to answer this question. A rotation, you need to know the direction. Is it clockwise or counterclockwise? And you need to know what is the point around which it's rotating. And the y-intercept is that point in this case. And this is clockwise. So it becomes an easy answer. Then A turns into C. Now, I haven't done the comparison part of this problem yet. Comparison will find this point of intersection between A and C. And that is also the point around which another rotation is happening. A will turn into C if all of A, here I'll use my meter stick to show it, if A twirls this way around that point, the point of intersection. And this way is this time counterclockwise. So the answer is, oh, I have to write a really long word, counterclockwise. Whew. Taking out the whole chalkboard. Rotation around, and I want to say this point, but I don't know the coordinates of this point the way I did for that point. But you know what? I don't need to know the exact coordinates to give a complete and accurate answer to this question. Around their point of intersection. Well, that's true, and it's an answer, and it's a good answer. Later on, I'll find the point of intersection because that's asked for elsewhere. If I knew it, I would write that point's coordinates instead of the phrase their point of intersection. But this is enough to completely answer this question. A turns into C if it rotates counterclockwise around that point. That is today's Daily Dose of Math. Please like, subscribe, and share. This time I'm answering the question, after how many minutes will A and C have the same number of sticks remaining? This is a comparison question. And what gives it away is when they say the same number, after how many minutes will they have the same number? It's that same number thing that tells you, okay, that sounds like a comparison. We already know the equations for A, negative 5x plus 90, and for C, y equals negative x plus 30. We figured those out before, and figured them out from the information that's given in the problem right over here. Comparison simply means we're making negative 5x plus 90 equal to negative x plus 30. I have turned two equations with both x and y into a single equation that only has x, and that's easier to solve. I'm going to keep the numbers on the left and move the x's to the right. So the 90 stays where it is. The 30 moves to the other side and becomes negative. The negative x stays where it is. The negative 5x moves to the right and becomes positive. We have 4x on the right and 60 on the left. We divide both sides by 4. These cancel and x is equal to 15. X is the number of minutes, so we've answered the question. It took 15 minutes. How many sticks? Well, they didn't really ask us how many sticks are left after 15 minutes, but we can figure it out. We have y equals negative x plus 30 for C's equation. The x coordinate at this point has to be 15, so y equals negative 15 plus 30. Therefore, y equals positive 15. The point of intersection, this point of intersection, is 15, 15. So if I want, I can make this answer shorter now. A turns into C with a counterclockwise rotation around the point 15, 15. Okay, now I'm going to answer the last three questions in our burning sticks situation. One of them is, what is the y-intercept of C in the context of the situation? It's the context of the situation thing that bothers the student. The y-intercept is 30. We figured that out because C's equation is y equals negative x plus 30. The y-intercept's 30. But in the context, you just have to say C started with 30 sticks. That's all the context of the situation means. They don't want the number, they want the number with the situation meaning of the number. Okay, now there's another question, which is, what is the zero for each in the context of the situation? We have discussed their zeros when we graphed it. The 0 for B is 9, the 0 for A is 18, and the 0 for C is 30. None of those are giving the context of the situation, though. So, zeros for A, B, and C. A takes 18 minutes to use all sticks. That's the 0, 18, in the context of the situation. B takes 9 minutes to use all sticks. C takes 30 minutes to use all sticks. Not so hard to answer a question about a y-intercept or a slope in the context of the situation, or in this case, a 0. The 0 is just the x-intercept. It's just another word for x-intercept. And finally, how many sticks will each of them have after 10 minutes? We have to take their equations and plug x equals 10 into them. Y equals negative 5x plus 90. Y equals negative 5 times 10 plus 90, which is negative 50 plus 90, which is 40 sticks. Say sticks. It's the unit of measure. B, y equals negative 10x plus 90. y equals negative 10 times 10 plus 90 equals negative 100 plus 90, equals negative 10. Negative 10, that doesn't make sense. You can't have negative 10 sticks. So, B has no sticks left after 10 minutes, of course. Then there's C, y equals negative x plus 30. I'm going to write it here, y equals negative 10 plus 30, which is 20 sticks, unit of measure. Okay, I've answered all the questions that went with this burning stick situation. It didn't have room to put the question in the usual spot, so I had to put it here. Okay, so really, if you understand, you're ready to handle a task about straight lines in the Math 3051 final exam. Because it was long because it's a task, it's worth a lot of marks. That is today's Daily Dose of Math. Please like, subscribe, and share.